Okay, hello and welcome everyone. Thanks for joining us on this session on explainable artificial intelligence in education. I'm delighted to be moderating the session with three renowned scholars in AI in education, Ryan Baker, Judy K, and Cristina Conati. I will be introducing them in a little bit more details as they start talking. So here's the general plan. I will quickly provide a very short overview of the context of explainable AI in education, and then pass it on in terms of questions to our speakers. Okay, so I guess it comes at no surprise to anyone in this conference that AI is set to transform the world, generating, a lot of dollars worth of activity globally, even currently, but by 2030 in particular, as one of the sort of timelines that we're working through. And automation and decision-making has been one of the increasing aspects of using AI. In particular, it's been increasingly used in high-stake decisions that have a significant and lasting impact on individuals as well as society. There are perhaps many other examples as well, but you can look at it in healthcare where, doctors are getting suggestions and coaching from AIs that's essentially having impact on patient lives, social welfare in terms of who should be getting more or less of available fundings from a government, lending, who's going to get money, mortgage or not, hiring, where automated decisions are being made in terms of who needs to be hired and not, as well as justice, where judges make millions of calls in a year about bail and releases, and in terms of predicting sort of what behavior a potential person would have if they were on bail or released. While there are many benefits in terms of having this automation and decision-making coming from AI, there are growing concerns about the fairness, accountability, transparency, and ethics, we call it FATE, of the decisions being made by such systems. One of the main aspects that have been looked at as a potential way of addressing some of these concerns is to use explainable AI. Explainable AI promotes the use of methods that enable human users to understand, appropriately trust, and effectively manage the emerging generation of artificial intelligent partners. And this image on the right kind of tries to highlight what this means. With the black box models, you'll have training data, machine learning process, you'll learn some functions and some decisions or recommendations will be made where the user just does not have an understanding of, what happened, how decisions are being made, who's being successful, who failed, can I actually trust this, or what are sort of the errors that might have been made. With explainable models, essentially the intention is to have explainable model alongside an explainable interface where the user can now kind of understand, why some decisions are being made, why some decisions are not being made, who's being successful, who's failing, who they can trust, and what sort of errors they may expect from this. Now, if you're thinking, well, explainable AI just sounds wonderful, why don't we just use explainable AI all the time? It does come with a bit of a trade-off. That if you look at this interpretability of the model versus the accuracy of the models, at least what we currently see is that sometimes the more interpretable models that we've got, such as rule-based learning, decision trees, logistic and linear regression, may not necessarily do as well in terms of accuracy to some of the more state-of-the-art methods in deep learning ensembles and SVNs. So there might be a trade-off that you're getting this explainability, but it might come at a cost of losing on the performance. Having said that, essentially, future research is looking into how we can actually make these models that are less interpretable actually more interpretable. So looking at this trajectory of the green line, we're looking at how we can change how we can make these better models also more interpretable. How does this tie into AI in education? Well, at the same time, and as we've seen so many wonderful talks in the conference, there are increasing use of AI in education. You can look at these in terms of AI in instruction. We're using adaptive learning, sort of immersive learning experiences. content creation, which is sort of the current world's excitement about GPT-3, how we can use AI in assessment and adaptive testing, grading, plagiarism detection, in terms of providing feedback, as well as in terms of allowing students to have more agency about their work, such as personalized nudges, recommending particular activities or scheduling tasks and learner models and profiles. So as we've had increasing use of AI in education, obviously similar sort of concerns about the fate in AI in education have been coming across, and they've been looked at by various scholars in AI in education in terms of, what are some of the methods that we can look into those. So last year, I, with some of our colleagues, had a go at trying to look at explainable AI in education, in terms of what that would look like if we want to bring that XAI into the education world. So Judy K and Cristina Conati on the panel were also co-authors of the paper that we looked at this together. And essentially, we argue that explainable AI in education has commonalities with the broader use of AI, but it also has its distinct needs. AI and HCI are main aspects of the XAI work that's happened outside of education, but we argue that, in terms of learning, the cognitive and learning sciences also play an important role in terms of how we understand it in education. We propose a framework and have some comprehensive case studies in terms of how that framework works. And at a high level, the framework has 6 dimensions. We look at the stakeholders, sort of common models that we use AI, current presentations of explanations, some benefits, some pitfalls and challenges, as well as effective ways to design AI tools. Enough talking from me. Just a bit of a context to put things into perspective. And we'll pass it on with a first question to our speakers, and then we'll have a few other questions. So maybe I'll start with Ryan, and I'll just do a quick intro. Ryan is professor and director of the Penn Center for Learning Analytics at the University of Pennsylvania. His research involves developing and using methods for mining the data that comes out of the interactions between students and educational software in order to better understand how students respond to educational software and how these systems impact their outcomes. He's internationally recognized for teaching the MOOC Big Data in Education and creating various tools for EDM research. Ryan, it's great to have you here. Thanks for making the time. Over to you.
Thank you. I'm honored to be part of this panel with such impressive colleagues. The question vanished right as I was about to answer it, but I think it was, what does explainable AI mean to you and why is it important? So, correct. I mean, I think your introduction was really great. I think explainable AI, if AI is not explainable, interpretable, or understandable, then ultimately we have a narrower range of uses for it. And in particular, I think that so often in learning analytics, we're providing an instructor, an educational stakeholder with a prediction of some sort. But if they don't understand why that prediction is made, they don't know what to do about it. Explainable is not exactly the same as actionable, but it's a lot easier to make something actionable if you can explain why you're making that prediction. And so I think that's what's important, is that explainability ultimately supports not just trust, not just understanding, but action.
I cannot hear Hassan.
My apologies. Cristina, we might go to you. So Cristina is professor of computer science at the University of British Columbia in Vancouver, Canada. Her research is at the intersection of AI, HCI, and cognitive science, with the goal to create intelligent, interactive systems. She is internationally recognized for her work on user modeling and intelligent tutoring systems. Thank you for making the time, and great to have you with us. Over to you.
Yeah, thanks for inviting me. So, yeah, I completely agree with what Ryan just said, that, it is, enabling understanding of the AI actions and recommendations and suggestions is definitely one way that can, convince the user, in our case, the students, for instance, to take over or take and accept the recommendations and the feedback and do something with it, right? And I think, in general, my take is that explainable AI is important because I see human AI interaction as a dialogue for, in many applications, right? And even in human to human dialogue, so many times as we're talking to someone and they come up with their opinions or suggestions or recommendations, we ask why, right? It's very normal because it's not necessarily always clear cut from the context. So AI in education for me is, no difference. And again, especially for students that are especially inquisitive or thoughtful or, care about the deeper outcomes of the interaction with the learning technology, they will want to know why a certain recommendation, a certain suggestion makes sense, right? Rather than just passively accepting. But I just want to say something that maybe I'll bring up again. So for me, one concept that is also important is that one size fits all explanations don't work, right? Not every learner is the same. Not every user is the same. So what works for one student would not work for another, even in terms of explanations, the need for explanations and what kinds of explanations, how much. So these are all, I've been kind of proposing this concept of personalized explainable AI, because for me, it's really important that user differences are taken into the picture when understanding where is the importance and role of explanations. That's true for general AI, but it's very much true for AI in education, because we all know learner differences are a crucial aspect of our research in general. So.
Fantastic. Thank you. Judy Kay is Professor of Computer Science. She leads the Human-Centered Technology Center cluster in the Faculty of Engineering and IT at the University of Sydney. A core focus of her research has been to create infrastructure and interfaces for personalization, especially to support people in lifelong, life-wide learning. She's internationally recognized for her work in AI in education, and in particular for open learner models. Great to have you here, Judy, with us. Thanks for making the time. Over to you.
Thank you. And I am absolutely delighted to be with my wonderful colleagues. Once again, still online, but that's life. Thank you. I certainly agree with everything I've heard before. Trust and so on are important. What I would like to focus on is something that's been my passion, and that is the sense that learners need to be in control. I think that's even more important in education than in other areas. Why is it important? Because learners need to be responsible for their own learning. They need to be able to be given the power to be responsible for their own learning. And there's another deep sense in which no matter where we go, we're nowhere near the point where we have very good quality data about learners. And so learners know a lot about themselves that the system doesn't know. And if we're going to build systems, we have to do it with that acknowledgement. But even all the tools, the wonderful range you showed, to me, it's deeply important that we build everything so that we start with the view that a learner should be in control and feel in control and feel it's part of their job to always be in control.
Fantastic. Thank you all for the introductions and putting things in perspective about, the importance of explainable AI in education. Now, there's a lot of talk about explainable AI in education, and I wonder if you can share, one use case, one exemplar use of explainable AI that you might have seen in your own work, in other people's work, that might be worth for the attendees to check out. And maybe for these questions, if it's okay, we'll use the virtual hands from the speakers for any of the questions I'll ask, that if you would like to respond to them. And if you have your hand up, I'll come to you, and then we'll move on to next questions. Judy, over to you.
Can I use my real hand for later?
Absolutely.
I have to remember to lower it too. All right, I cannot help but mention open learner models. It's been my passion. One of the things, we do many things. AI means a lot of stuff, so it's very dangerous to say things without pinning things narrowly down. But one important thing we do is we collect data about learning and about an individual learner. Sometimes we aggregate it to build a model of lots of learners, but I'm particularly interested in the case where there's data about me and my learning, and a thing called an open learner model. I've struggled with the term. It was invented almost 2 decades ago. And it's not a brilliant term, but I think it's the best we've got. And what does it mean? It means that when we collect the data, we start, or the vision I have is that we say, hey, let's build all the collection processes and all the things we do with that data with the assumption that we are going to use that to help a learner understand their own learning. If it's also used to drive a teaching system, that's cool too. But we should start again with the user having control of their own data and able to use it. And there have been several very nice studies that showed that it improves learning. There are various interface elements. We don't have time today to go into them. But for example, my colleague, Vincent Eleven, has these very nice studies where asking a student to think about how well they know something, as it happens, it's maths, and then showing the system's model improved their learning. Now, you know, all the education theory people won't be shocked at this, but that doesn't mean you get it right when you build the interface and you make it. Tanja Mitrovic, another of my colleagues, has done probably some of the earliest work in that area, really showing that you can really improve student learning. And this is because we actually start by saying, hey, we really want you to understand what the system is collecting, and it's not just to drive smart teaching, it's to let you understand yourself and potentially to control where you go. There are a bunch of other really nice examples of open learner models.
Thank you. Cristina.
I managed to raise my virtual hand. Wow. Great. So, and yes.
I just want to say, if there was an open learner model showing which bits of this interface you understand and which you don't, based on the fact that this thing's been watching you a long time, it could help you find the stuff you need to know, especially since the word raise your hand was used in the dialogue. Sorry, let's go on.
Yeah, and so certainly following up on Judy's comment about, first of all, the importance of learners' control, user control, but here we're talking about students, and learners. That's an extremely valuable point, and for sure, giving access and the possibility to look at explanations to the extent that the learner chooses, it's very important. And in terms of an example of a use case, something that has been kind of, we were trying to move one step forward from the open learner model. That is very important because of all the evidence that Judy mentioned on, how effective it can be for users and students to get that information that can sort of like trigger self-reflection. We also wanted to see if we could provide explanations for the teaching aspect. So how the ITS uses the collected information on the students to drive interventions. And to us, this was a huge challenge because the underlying AI, so it's the whole pipeline, right? There is the user modeling that was already in itself rather complicated. And then there is the decision-making that the tutor does. And we were trying to find ways to convey all this to students who wanted to look at these explanations in a way that was digestible and not overwhelming. Spent a lot of time trying to design an interface that would be incremental in the sense that users could choose at what level of detail, explore the different concepts. And so we were quite surprised that we did have some good results in terms of explanations working for some of these. This was in the context of a system providing feedback and support as students were engaging in open-ended learning with an interactive simulation. So we did get some interesting results showing, again, that explanations can be good even when they're so complex for some learners, and others might need a little bit more support and help in order to appreciate or benefit from the explanations. But I think the results are encouraging because one main difference between perhaps education and other fields is that during the learning process, the student is already so much engaged in learning that in itself it's a difficult task, that injecting explanations on something that is also very complicated, like the underlying AI, how to do it right so that it doesn't become overwhelming and intrusive. I think it's even perhaps more challenging than in some other fields. So I find this to be a bit of a, specific aspect of explanation in AI in education. So this work that we have been doing shows that there are ways. It's very, to do it right takes a lot of work, but it's worth the effort. And I think more of us should engage in that, because the more examples we have of different tutoring systems, different educational applications, the more we can understand how to get it right.
Thank you. Ryan, you neither have your virtual or physical hand up, but I'll just check.
I should have my hand up. Is it not?
Oh, I'm sorry. It's just fading into the yellow, your background.
Oh, I didn't see that. Oh, I see that. It's true.
Oh my gosh. Well, I'll change the background. This is not.
I apologize.
Okay.
I'll just go around on all the questions anyway.
Now that we know, we can see it.
Yeah. Over to you.
Well, so, I mean, I'll only say a few words, because I think my colleagues had such great examples. I'll say a few words just on our work with the Bright Bites early warning system, which is a system used by a lot of school districts in the US that predicts whether a student is likely to drop out of high school. And in that system, we took a kind of unusual step with our explainable AI, in that a lot of explainable AI systems directly provide what the algorithm, the immediate algorithm, why it's making its prediction. And what we do instead there is we take a lot of the factors that are correlated with dropout, that are most interpretable and most actionable. And we give an overall prediction of a student's risk level, but we break it down rather than saying, here's the reason this student's most likely to drop out from the model, because that can be kind of a little bit idiosyncratic and model specific. What we instead do is take these factors that are known to be correlated and known to be predictive and known to be actionable, and we provide a recommendation in terms of those. So it's a case where what we found is that actually having something that's not quite as loyal and explainable AI actually helps to be more actionable in terms of taking the AI's overall prediction and breaking it down into action.
Thanks for sharing, everyone. Yeah, really insightful examples and quite different ones. So great to hear from those. In the audience, if you do have questions, please do post them either on Zoom or on Wova, and we will go through some of those questions soon. I want to follow up with talking about how we can better prepare our teachers and learners for explainable AI or understanding AI models to begin with. Do we need to think about AI literacy? Or can we perhaps make their explanations so clear that there is no need for sort of AI literacy there? And if so, what are some of the steps that you think we might need to get there? Because while I really like all the examples we've had, unfortunately, AI or explainable AI in general, I wouldn't say that's well adopted in our current educational systems. If we want to actually get it adopted at scale, what sort of preparations we might need to have for our learners and educators? Cristina, go.
So yeah, that's a great question. I think utopia is they would need no preparation because our explanations would be wonderful and clear and everybody could understand them with zero background, right? To what extent, I mean, that would be the long-term, the best outcome. But to what extent that is possible, I think it's very much an open question, just because the research on even, at what level the explanations are needed, what kind of explanations is so, still limited that I think we definitely need more of that and more studies that are really just about asking the users beforehand, right? What they need from the explanations, how much they would want explanations, because again, as the example Ryan brought up, right, there are different types of explanations that you could bring, and some of them would not necessarily require a deep understanding of AI if you're just presenting the important factors that we're taking account for the prediction, right? They should be related to the task, and so not requiring any deeper understanding of the AI techniques. But if there is a sense that an understanding of the mechanisms themselves at some point, the how, right? The how explanation, if that's something that at some level could be useful, then how to generate a how that talks about mechanisms in a way for someone who might not have any background in AI could be challenging. So I think it's really a great question, and it's something that we as a field really need to think about. And for me, getting an answer really involves to do empirical studies that, even if you don't even have explanations yet, right? But sort of proof of concept studies where we ask the users, the students, right? And the other possible audiences like parents versus other stakeholders. What level of sophistication they need, right?
Thank you, Judy.
Okay, I was going to let Ryan since okay, I'm very happy to do that. So first of all, I want to talk about some work we did quite some time ago where a student of mine built a system that was personalized. And it started by asking you things you preferred. Did you like to get jokes when you learn and so on? And it gave you a pretest, and it did the personalization completely wrong because it was meant to be explainable, and we hoped that would trigger people to try and work out why the hell it was doing the wrong thing. And what we actually found, firstly, there were 3 learning phases and each one had a quiz. And at the end of each quiz, there was a spike in interest in exploring why the thing was doing what it was doing. And that kind of makes sense. But in some follow-up interviews, when students were asked, didn't you notice it was making mistakes? One common response was, yeah, sure, software makes mistakes all the time. I just live with it. So I actually think one of the biggest problems we have is getting people to the point where they say, I should be able to explain something. That's one big challenge. If people are used to the fact they don't understand the world around them, and let's face it, let's not get philosophical here. There's a lot I don't understand in the world. But when it comes to computer systems that were artificially made, they should be built so they could be understood, and people should, again, this idea of control and power, we should, as users of systems or learners, we should believe we can dig into how they work. And that's something that's that's nothing to do with a particular AI technique, right? It's just a belief you should be able to. We've got legal things hinting we kind of like that. Second thing is we have to be aware, we've got a life to live. If you're a learner and you're learning maths, you don't have forever to spend working out how the system works. And so we have to do stuff so that when you've got a little snippet of time, you can get something, this little snippet that's useful. And as Cristina, actually, we had a perfect example with Ryan. The interface was a problem. We couldn't see the hand because the interface of the background, the color was no contrast. They could have built the interface better, right? They could have, technology certainly could change the hand so that it's visible. Building interfaces is already hard, and building ones for this is going to be even harder. And I guess my fourth comment is that in the AI community, we put a lot of effort into explaining complex algorithms. There's a lot of papers on that, and it's not unimportant. But hey, a lot of the time we base stuff on data where the learner knows that when they were doing these assignments, they got it from, say, ChatGPT, or the person sitting next to them told them how to do it. And they know that, and the system doesn't. So at the very least, if a system said, the reason I think you know this topic is because of this particular data, the learner could at least, again, they're in control, they know what's going on, they could say whether they trust it or not. slightly different slant from Christina's.
And I love how you're scrutinizing Zoom. Why don't they change the color here? Why isn't that explainable? Love that. Ryan, any additions from you?
Sure. I mean, I think my colleagues had great things to say here. I would just add the point that I think no matter how good our explainability and our design is, we're ultimately going to be at the point, Judy, I think your example of the users who say, well, we don't expect the technology to be that good. Actually, that's a pretty cognizant and literate individual. Because I think a lot of people, when they deal with diagnostic models, be it in education or in medicine, tend to have this folk belief that they tend to try to generate folk beliefs. And among the folk beliefs they often come up with are, it's perfect or it's wrong, right? And I think most models, most predictions are wrong. That's how you get all these people during the last 3 years who are like, well, my test came up negative, so I can't possibly have COVID or give it to people 3 days from now. People also get folk beliefs where they massively oversimplify how the algorithm works. And then when it doesn't work in that massively oversimplified way, they get angry at it. So I think developing people's ability to, regardless of how much the algorithm tries to explain, an awareness that it's going to be wrong sometimes, that it may or may not be better than nothing, and that oversimplifying is unhelpful. Those kind of heuristics and those understandings and that literacy, I think, is really key, regardless of how good a job we do with explainability, because we'll never get it perfect.
Yeah, thank you. I like Christina's thoughts about, the utopian world of essentially not needing any sort of explanation. And maybe in some applications that's already there, just thinking about Amazon or Netflix, you're getting this because you watch this other thing. I don't need to have AI literacy to understand that's why that recommendation is coming to me. Or if you look at Google Maps, it's going to give me an estimate of when I'm going to get from location A to B and the path I should take. I can just visually see it. I don't need to understand how they've calculated it. And maybe some aspects of that utopian world of making it so easy to understand that you don't necessarily need to be AI literate is a good way for us to think about it. And also just building on that, having these multiple layers of very sort of high level, this is what it means, but you can then drill down into the explanation to ask questions about it. And I guess, Cristina, that comes to your sort of sense of personalization. Do you want it at this level or do you want it more detailed at this level? And based on the preferences or the ability of the learner are sort of exciting avenues to look at as we think about this question. I'm going to go to questions from the audience, if that's okay. So one question is about, how do you think specific areas in AI education that AI can make promising impact in? And I guess I'll just add one thing to that as we're getting responses from everyone is a lot of the initial work on Explainable AI in education was coming from the CHI, HCI community. Now, there are aspects of that I think we can borrow from as we think about it in the context of education, but are there perhaps things that we can contribute to that dialogue and that discussion, which is coming from the learning sciences and the learning aspect, which perhaps people in the HCI community might not have thought about as much?
Well, let me just jump in with a quick thought, which is I think that it's important to have this wherever people are going to have to make a decision based on the information they're receiving, based on the AI. And the honest truth is I think that that's almost all the time. I find it hard to really envision many cases where better understanding is not going to be beneficial. I mean, I like Christina's utopian vision as well. There might be some cases. I don't want to, whenever you make an extreme statement, that's always wrong. But I think we can always benefit from better understanding the things that are impacting our lives, be that in education or other domains.
Thank you. Judy or Cristina, any additional thoughts from either of you on the question?
So I think one of the things that, especially things like ChatGPT, that splashed just a week ago, though of course its cousins have been around for a lot longer. I'm struck by the fact that it's really going to force us to be clear on what it means to know something. Because ChatGPT actually doesn't know very much in a sense that humans would value. And the fact that it can do so well challenges us to think carefully, you know, in education, why do we need to know? What do we need to know? How do we use tools like this, but still maintain our own learning? And obviously there are challenges for teachers because I'm marking exams at the moment, and we all know that, you know, the student who writes an excellent answer is easy to grade with full marks. The one who leaves it blank is easy to grade with 0. But pretty much everything in between is tricky. And this is where a lot of what we get is probably no better than GPT-3 would pop out to a lot of the questions we would like students to learn to be able to answer. So one of the challenges will be for us to work out how to manage in this world, but also to have learners really understand both what they need to know, why they need to know it, and why it matters. Even when we've got these tools, it's not so different, I guess, to the calculators, right? Or I'm told Aristotle was upset about the technology of writing, damaging people's ability to learn things off by heart. We've worked out an accommodation, but I think this is going to be a very exciting way to challenge how we think about education, hopefully for the better. And I'm not sure if that answers the question.
Thank you.
And I think, you know, I guess the initial question was where AI can help in education, right? And I think I'm going to use this question to bring up the fact that, you know, there are different stakeholders when we talk about education and AI in education. So we have been talking a lot about the learners themselves, right? But there's also the teachers, and there are also possibly even policymakers or the parents, right? So I think these are different stakeholders that might have, and I think AI in education can be helpful for all these different constituencies in different ways, right? But for instance, one can imagine helping a teacher manage and get sort of overview of how the class is going, suggestions on how to address specific learning circumstances and situations, specific learners or groups, and so on and so forth. For parents, you know, possibly allowing them to get a bit better insights on what's happening with their child. And these are all things that as a community, I think there has been a lot of focus on the learners, definitely work on support for teachers, maybe not so much for parents necessarily, or who knows, even policymaker, but it's all, you know, these are all spaces that might require further exploration. And for each of them, this idea of, you know, where explanations sit, what level of explanation, what types of explanations are, you know, the answers might be different for the different stakeholders. There could be, you know, it would be great to understand what are the common factors, right, that cut across these different audiences, and what are the things that are specific to each group.
Yeah, thank you. I'm going to jump to a question from Lisa.
Could I just add one thing there, and that is it's very easy, especially for me, to slip into thinking about my life and my very first world privilege. There is a very large part of the world where we are very short of teachers with expertise, and technology is getting a lot cheaper. So we do have some incredible opportunities, these global development initiatives. I do see there being huge opportunities to not have to build a whole generation of teachers independently before you can actually help the population move ahead. I don't see it happening a lot yet, but it surely is a potential. Sorry.
Thanks, Victor. Yeah, absolutely. Going to Lisa's question, if it could get educators to analyze their own decision-making process, wouldn't that be good preparation for understanding NXAI? Or I guess to build on that, to what extent are the decisions coming from our instructors currently explainable? That we're holding AI to, accountable, wise, and explainable. Just to add to that, what methods do you think are currently being used by instructors to explain their decisions? And is there anything that we can learn from that in terms of how we move it to XAI?
Okay, so I hope others will pull in. But first of all, human beings are really tricky, right? First of all, I don't understand myself super well. So even if I were totally honest, I might not necessarily really know. I mean, the psychology is full of these studies to show that we misjudge our own understanding and drivers. And there's this beautiful metaphor of the elephant and the rider. And we think we're making decisions, but in fact, when we make decisions, we're a little rider sitting on the elephant. And really, when the elephant, our subconscious, decides to take us somewhere, it does. So there are limits. This is actually one of the important things. We actually build this technology, so we ought to be able to build it so that that's less of an issue. So that's one. But in terms of teachers sharing, I mean, we all know, is it really a good idea for me to tell you everything I think about you? Or as a skillful teacher, do I tell you what is useful for your learning in my assessment? So I guess the two issues, self-knowledge, and secondly, the goals of communication. But I think there's also a growing body of work in not education, but in, say, predictive models, that experts are not as good as even linear predictions because we're not as consistent. And one would expect that's probably true of education. But also, when a human being sits down, they can sit with the student and negotiate the discussion, and everybody can learn about each other in a very powerful way, with humans interacting with each other and getting all the things that humans are about. That I think is deeply important, and maybe is a bit of a digression from the question.
Yeah, no, thanks for sharing. Though I would say, teaching a class of 800, the possibilities of sitting down and discussing things with students doesn't seem to be that plausible. But at least for edge cases of their questions, you can have sort of a humanly discussion to overcome the challenges.
Yeah.
Cristina or Ryan, any?
Yeah, and I think also a lot of it depends on, what pedagogical decisions we're discussing here, right? Because you can go from as low level as marks on an assignment or feedback on an assignment versus, justifications of specific pedagogical decisions made on the material that is presented, say, at university level for a course, right? Justification of specific strategies. Why am I giving you 5 assignments instead of just 2 midterms? Or these are all things, right, that some students might ask about, and I've had students ask about them, or sometimes you just want to justify them to bring the class and the students on board for what you're doing, right? So there is many different levels and many different pedagogical decisions or actions that make up the learning experience, especially if we're talking about a full course, right, or a classroom, that, again, to what extent the teachers can and want and need to verbalize and explain, it is very much dependent on what are we talking, as Judy was saying, right? Sometimes you don't necessarily want to say everything that should be said because there are issues of sensitivity to the learners, how the learner could receive that information, right? So there is a lot of that to take into account. So there is not necessarily clear-cut answer, I don't think.
Thank you. Ryan, I might jump to the next question with you, especially since you've already touched on it a little. Are there any pitfalls in terms of providing explanations that you can think of? We've talked a little about the benefits. Is there potentially a downside?
I mean, I think there's lots of potential downsides. It's all about how it's done. For one thing, quite simply, I said a minute ago that we should be able to explain everything, but that doesn't mean we should explain everything every time. If you imagine like every single time you use your phone to get Google Maps to navigate somewhere, or every, and it tells you, here's how I made this decision and why I did it this way. That would get annoying and time consuming and useless. So it's got to be kind of turn offable. It's got to kind of be able to scale up and down the amount of information that it gives in any given case. And I think also explainable AI, depending on if your model works in certain ways that are correlational, that doesn't, and it's too close to the model, then it can actually create folk theories in the head of the person who's, the way that you explain how the model works is going to become the model of how people think the model works. And if the explainable AI is inherently an oversimplification, people may adopt your oversimplifications. So if I'll take the example again of high school dropout, if the model says you were absent 7 times, so I think you're more likely to drop out. Well, somebody might get the idea that dropout is as simple as absent 7 times, right? So I think that explainable AI, if poorly designed, can create inaccurate models in people's heads. And I think that's something to be very careful about.
Right.
And just following up on that, if I can, there are these 4 principles that Kulexa and colleagues have laid out in a Kai paper from a few years back, right? And there are specific high-level properties that you want your explanations to have, right? They should be sound, right? They should be not misleading, right? They should be complete, right? So at some point, enable the user to get a picture of everything there is to know about the model, right? And they should be, so it's 3, not 4, and they should be iterative, meaning that the learner or the user should decide at what level, right? And no, actually it is 4, because the 4th one is not overwhelming. So, and the minute you bring not overwhelming after having said that you want them to be complete, right? That's where it's like the big conundrum comes, because they need to be complete and not an oversimplification that would create misconceptions in how the model works. Then it becomes, how do you explain a model architecture and decision-making processes in a way that is complete, that is sound, and not overwhelming? That's where the big, I think a lot of the research needs to go. Because again, we don't want to necessarily explain everything all the times, right? But it is very important not to err in the direction of oversimplifying and misleading the user into thinking something about the model that is not true. So there should be a level where if the learner or the user wants, they can go all the way down and explore every aspect of the model, right? How to do that in a way that it's usable, that keeps the user in control, not overwhelming. That's it's a big research question, but very important.
Okay, I want to link up with one comment that's in the chat, and from Jeremy Rochelle about uncertainty. And Ryan's actually also touched on it. Obviously, there's uncertainty in a lot of decision making and model building in general. And one of the hot topics in information visualization at the moment is building better interfaces that communicate uncertainty in ways that people can understand. And Colleen, there have been a number of studies, but Christina's done some on various forms of people understanding graphical information and the challenges even of understanding graphs, let alone ones with uncertainty. So I do think that we've kind of neglected the whole issue of thinking through not just how to explain, but even how to really do a good job of modeling our uncertainty. And maybe that relates back to the human teacher. I mean, but would we like to tell students, you got 70, but I'd say that's really 70 plus or minus 15, if I was honest about the accuracy of marking.
Fabulous. Gonna go back to one of the questions from the attendees. Now, if explanation is critical in education, does that essentially mean we need to say, you know, goodbye to deep learning models or state-of-the-art AI in education?
So state-of-the-art AI in education are not deep learning models, right? Because usually we don't have even enough data in some, I mean, for MOOCs and other applications, we do have maybe data, right? But for a lot of systems and research endeavors, we don't even have enough data to go into the deep learning, right? So if we can ever go into the deep learning, then it's a great question, right? Should we say goodbye to explanation? Should we not even consider that because it's too difficult to interpret, right? But, you know, there is a lot of work on making deep learning models more interpretable. But, you know, I think the first step should really be for all the other, I mean, your curve that you had, the graph that you had at the beginning, right? There are some machine learning, but also a lot of the things that we were discussing, this is like to equate machine learning and AI. AI, it's a little broader than machine learning, right? And there are models that have been used in AI in education. They are not necessarily machine learning models, but for inferencing and decision-making that have been successfully used and are potentially more transparent, right? Thinking about the cognitive models, cognitive tutors, for instance, right? Or systems based on Bayesian networks. They are more transparent than deep learning models by nature, but the issue of how do you present these mechanisms, these processes to users who should not have a degree in AI remains, right? So I think it's very important to start working with these models that are more transparent by nature, but they're still complex. And how to explain those is a challenge. And then while we do this, we can wait for the work on interpretability of deep learning models to come up with something meaningful and that we can see, right? But, you know, I wouldn't say goodbye to them, but I definitely would say let's not just jump into them to look at explanations, because that would be an added level of complexity for sure.
I also would add that I think, you know, one of the solutions right now, the explainability AI work on those kind of deep learning models has issues, right? Like Vinitra Swamy had a neat paper not too long ago on showing that sometimes the explainable AI things disagree, you know, for the same algorithm and case. But I think there's a lot of things we can do to try to distill what's going on for people. If you get much better prediction, I don't want to throw that out, right? Like I want to know which students to focus on, or I want to know what a student knows. But to the extent that we can't, you know, entirely interpret the deep learning model, we can at least try to figure out what the story, what's going on maybe with a simpler model. So that's another option, is you use multiple models at the same time for different purposes. I think there's a lot we can do. I don't want to throw out the baby with the bathwater, so to speak.
I think we do have to ask the question, though, how much more are you getting for the more complex algorithm? I mean, as Cristina points out, for education in particular, we have a lot of cases where we really want to do learning on small data. You know, we'd like to understand our class. Huge numbers. Okay, if you're trying to understand the nature of the learning of mathematics, you could probably have data from, you know, thousands and thousands of students, presumably all brains progress in some ways that are consistent. But, you know, a lot of it is affected by the context and a million other things. And so I don't actually think that in education, this question is quite as important as it might be in some of the others. I don't see the trade-off as necessarily being as big. And the one thing we should ask is the accuracy, the inaccuracy of the model. Because it galls me when I see papers which come across my desk and people are modeling something like emotion of a learner or user. And hey, you know, we know how lousy that can only be. You cannot get that accurate. And then they put tables of algorithm A versus algorithm B and C and D. And they've got 7 significant figures. And they compare these numbers. I mean, it's ludicrous. Yep. And it just reflects that our research community isn't thinking, hey, look, one significant figure is all we can justify here. And even then the error bounds are big. And if 2 algorithms are pretty close to each other, then there probably is no difference. And my colleague, Kalina Yosef, had a paper that won a data mining challenge. And she was very embarrassed because she and her student actually only entered initially. They ran out of time. They did a base case where they predicted the result of something just on one of the parameters, just really simple, just because they were going to use that as their base, right? But then they ran out of time to do any more, and yet they got there were 3 prizes and they weren't ordered. So they got one of the 3 prizes because on unseen data, they did just as well as the fancy models. And in education, that does not surprise me.
I'm sorry to speak twice. I feel like I'm breaking the rules here, but Judy, I agree with everything you said there, and those papers just make me so upset too to see when people do that at the 7th decimal place. I will say, however, that I do think there are cases where these kind of, recurrent neural networks and deep learning models actually work quite well in education, even for small data sets. The cases where you can use a pre-trained model and build off it. Some of my grad students have been using pre-trained models for some NLP problems and getting like 0.2 better, like, in the first decimal place and, the tenths, and getting 0.2 better. And boy, that's a huge difference. So I think it's case by case.
Yeah, and I would agree that, there are times when we want to deal with small data, but we also have applications where we have a lot of data, right? Even thinking about assist, for instance, of some of the MOOCs, right? So with new technologies, we are having, space for research that can leverage large amount of data. But I think, I totally agree with Judy and Ryan. The important thing is really try to compare, right? How much is the deep learning obscure model buys you in terms of accuracy? And, at that point, it's all about the trade-off: more accurate, less interpretable, until someone makes it more interpretable. But let's say for now, less interpretable. And the other one, less accurate. By how much, right? But more interpretable. Which one do we want to choose, right? As long as it's clear and we have we have data on accuracy and then explainability, then we can decide, right? And again, the answer might not be always the same, right? It might depend on the context, might depend on the application, but getting that information in the first place is important.
All right, thank you. We're almost out of time. I just want to do one last very quick round with everyone. If there was one thing that you would think, is very important for the future research on explainable AI education, and we've got members in the participants that might be interested in working on, very quickly, maybe 20 seconds or so, what would be your recommendation of one thing to look at? And then we'll wrap it up. Cristina.
Finding money for the research.
Thank you. Judy.
I think more work on personal data about individual learners and the whole story around that, because I feel it's been neglected, but it's got potentially high payoff.
Right.
One thing, 20 seconds. I think figuring out how to understand how people understand models and work with that so we can help them understand better and not make silly assumptions. That'd be really great.
Thank you.
And since my answer was a bit of a joke, I just want to say I do have 10 seconds. And to me is, following up a little bit about really this personalized XAI. So try not to make this blanket statements. There's people will want explanations. I think it's very important to understand where, what are the differences and different aspects of the learner or the teacher or the parents that need to be taken into account to deliver successful and useful explanations.
Thank you so much. Thank you all for joining us today. I apologize we didn't have time to go through all the questions that were raised. I want to thank Ryan, Cristina, and Judy once again for joining me today, and enjoy the rest of the conference, everyone. Thank you.
Thank you for inviting us. Thanks so much.
Thank you,
Bye-bye.
Hassan, for organizing.
Bye. Have a great day.
You all.
Bye.
Bye-bye.